Awesome. It's show time. Hi, hello, good morning, good evening, to whichever part of the world you're joining from. How are you all doing? I'm Mudit from DPhi, and with me I have Supreet from Databuzz. Hi, Supreet.
Hi, Mudit.
I think let me just give a quick shout out to all of those who are joining us live. So, can you hear us across various platforms? I'll also try to go and check myself, but you can hear me. Just let me know via comment or something. That'll be great. Yep. Think seems good to go. Also, one thing that I saw in the last, in a few sessions that we have hosted lately is that a few times people, the community members, they come forward and introduce themselves in the comment section. That's a great thing. So if you're joining live, you can actually put in your quick comment for other people to um, join you on LinkedIn or any other platform that you're joining from. That will just be a great community activity. Um, I'll get started in terms of a quick intro of DeFi, and then Supreet can introduce Databuzz. And the reason I'm thinking of doing it is because we notice that in every session we get an opportunity to host a few new set of members in these live interactions that we host with AI leaders on a weekly basis. So a quick intro about DeFi for those of you who do not know about us. So I happen to be one of the founding members of DeFi. Um, the goal that we are chasing at DeFi is to build an ecosystem which educates and builds AI for all. And with this, we started off by creating a free boot camp around 2 years ago. And since then, we have been creating a ton of learning resources around data science. All of them are contributed by people who are joining from various parts of the world, and these are completely free. So not just this live session, any of the boot camps, courses, or challenges that you see on our platform will always be free. And we're thankful to people like Supreet and Manu, who is in the backstage, who come forward to help us in our mission and educate the community. So kudos to them. Now, Supreet is the founder of Databuzz. She's also an AVP at Morgan Stanley NY. So maybe Supreet, you could give a quick intro of what Databuzz is.
Yeah, sure. Thank you, Mudit. So here I am again, and I think we've been doing this from a while now. That every Saturday I get to co-host a few sessions with Mudit, and we also have a few sessions in collaboration of DataBuzz and DeFi. So DataBuzz, as Mudit describes, it's very similar to DeFi, but it's one of its kind, volunteer-driven community. The goal is again to engage tech enthusiasts like me and update you on information on AI, data science, and whatever is happening around the globe through articles, through these sessions where we invite speakers, through fireside chat series where we celebrate people who have taken a path that is unconventional, like most of us. So you can check all of that content on Databuzz LinkedIn page and Databuzz YouTube page. So thank you all again for tuning in, and I'm really looking forward to again another awesome session.
Awesome, perfect. So now we'll dive into the session, drop a quick intro. So most of us know, right? The agenda today is so we'll definitely interact with each other. I can see Chriselle has dropped a quick comment. Hi, Chriselle. She happens to be our speaker from a recent live session that we did with Databuzz. Hi, OS. I can see a few more comments on various other platforms. So hello, everyone. Good to see you all. To talk about, okay, my screen just went off. I guess I'm still live. I'll quickly introduce about today's session. So we're talking about zero short text classification. Okay, it's an interesting technique. So I think I wouldn't dive much into description because Manu is definitely a better person to go about it. But what I could understand, it's something which has been seeing an increasing interest from the research community because of the way it works. So it uses very minimum amount of label data to build a text classification model. Okay, and that's an interesting thing to do because labeling data and getting a excellent data set to work on is in itself a big problem statement, and this technique aims to solve it. Now, the speaker for today's day, Manu, he's a data science leader. He's a self-made data scientist, so that's a great thing about him. He has worked across various sectors and domains. So he has been a software engineer, analytics leader, and he's currently the head of applied research at Thousand Trick. He's also the creator and maintainer of a PyTorch Tabular, and he has been contributing to NLTK very proactively. In fact, he has enhanced several language model selection libraries on the, by introducing many statistical language models. So that's about Manu. I'll probably loop him in for him to introduce himself to you all and get started with the session. So yeah, hi Manu.
Hey, hi. Thanks, Mudit, for that wonderful introduction. And I think, yeah, Mudit covered pretty much a lot of the intros, right? So, have about probably 10 years of experience across different domains, as Mudit said. And almost six of them is in analytics. I slowly transitioned from software to consulting to data science completely. And currently, as Mudit said, just heading the applied research division inside Thousandic, where we try to kind of bring cutting edge research into value added products for our customers. So yeah,
Okay.
that's yeah.
Oh, that's interesting. So probably Supreet and I will go to the backstage and leave the stage to you for you to lead the session. By the way, the community members, for those of you who do not know, you can absolutely feel free to ask anything that you want to. We'll be seeing every single question that you might have, so you can put it across for sure. We'll pick them towards the end, so stick along. Yeah. So Manu, the stage is all yours.
All right, all right. So let me start my presentation. Okay. All right. So yeah. Oh, right. So today we're going to talk about say zero shot learning, right? Zero shot text classification to be specific. So it is kind of like Mudit mentioned, it is an up and coming field, and it is a very interesting field because of this fact that you don't need labeled data to do text classification. So through the session, we'll just look at a few techniques which is easy to use and accessible to everyone, and we'll also cover a few limitations and how to make our models better, etc., etc. Right. So let's start off the whole thing by looking at the standard paradigm in which most of our machine learning works. It is the supervised learning. So let's say that you have this hypothetical data set that you have a lot of cats, dogs, and horses labeled, and you've trained a machine learning model which knows how to predict all of these things, right? But the moment you kind of move away from these standard known labels, like even something which is very similar, like you show a zebra, right? The model will be flummoxed, right? It'll not have any idea of what that is. And that is actually an inherent flaw in the way that we are designing our models, our learning paradigms, right? That's where the zero shot learning is slightly different in that aspect, where let's say the very similar scenario, right? You have a lot of labeled data sets like dogs, cats, hyenas, whatever, right? Except that there is no zebra for this example's sake. And in addition to all of this, let's say that there is also world knowledge, right? I'm just denoting it by Wikipedia there, but let's say that world knowledge is also available for the model to learn, and this model is learning in a way that world knowledge is also related to everything that it has already seen. So in such a situation, if we show the model the photo of a zebra, right, then I think the model can kind of figure out some, it's like it looks like a horse, and then from its world knowledge, it knows that okay, a zebra also looks like a horse, and it does have stripes, black and white stripes. So using the world knowledge or common sense, many different words for this, so the model will be able to kind of figure out that this is zebra, even without seeing a zebra in its training set. So that is the whole kind of charm of this particular paradigm. And at this point, you might be thinking that okay, this looks very similar to transfer learning, but there is a very a subtle difference there, right? So transfer learning, as you all know, especially in NLP, has been the rage these days ever since BERT came up, right? So a very standard format of applying these large models, these large pre-trained models, which has the world knowledge inside, to different tasks is transfer learning, right? So you say that you have a pre-trained BERT. Let's say we have a pre-trained BERT model. Let's say that the model is BERT. And then I want to use that model for a sentiment classification. So what I'll do is probably I'll pick a few sentiment data set, sentiment classification data set. I'll just do a fine tuning of the model. I'm not going into details of the fine tuning aspect, but then you do a fine tuning of the model, and then the model will be able to understand whether it is positive or negative, right? And the same pre-trained model, we can kind of fine tune it to say that recognize news articles, whether it is science, politics, or any other things. So that is another model or another fine tuning that happens, right? And if you notice, in both of these situations, you do need some label data to do this. But the zero shot model is kind of like you have zero labels, you have the model trained, and the same model will be able to tell you whether a particular sentiment is positive or negative, and the same model will be able to tell you whether a news article is science or politics, right? It is similar to what we, like, as humans are, right? Like, we don't need to train ourselves separately and different models and different brains, right? We just use our knowledge to kind of infer what is what. So that is the key difference in zero shot learning. In NLP, right, there are a lot of, well, actually a lot of different ways of doing it, but we'll just cover these three major ones, which is easy to understand, easy to use, and because of a lot of open source development, which is very simple to implement as well, right? So the first one, what we'll be looking at, is the most simplest approach of them all, is something that's called latent embedding, right? So um, so computer vision and NLP has one key difference. So in computer vision, the input is in images and the output is labels, right? It is text. But NLP has one advantage over this, is that the input, which is the text that we have, and the label in the text classification scenario, the label, are both text. And because of that reason, both can reside in the same space, right? Same embedding space. So we can leverage this particular property to kind of use or to come up with a way of doing zero shot classification. So let's say that you have a text. Let's say it's who are you voting for in 2020, right? And there are three labels that we want to kind of see, right? Whether it is politics, economics, or public health, right? So a way that we can do this is we can use a text encoder. There are many available. Sentence BERT is one of the better ones, which is basically like a Siamese network type, which is trained to give good sentence representations as opposed to other tasks or other word prediction tasks, etc. Right? So we can use so you can use as SBERT encoder, and you take this your input text, you encode them into the embedding space. Let's say that if you have 7 words, you will have 7 plus 1, as in the CLS token will be there. And then what you can do is you can just take a mean pooling, like you take a mean across everything, you get a single vector now. And this vector is the sentence embedding, right? It is the representation of the sentence that you've input into the text encoder. And similarly, you have these three labels. You can encode these three labels also using the same encoder into a shared space, right? Under an embedding space. Now, if you look at it, this sentence embedding and these label embeddings live in the shared semantic space. So now it's as simple as looking at which of these label embeddings lie the closest to the sentence embedding, right? You can use cosine distance or any other distance that you want. And whatever is closest, we're going to say that that is our label, right? So by using this, what we've done is we're not using any labels or anything like that. We're just using the common sense, which is encoded inside the text encoder, which has seen a lot of data in the internet and all that, right? So using that information, you're trying to kind of say that, okay, this text can be about politics. And now how can we make these things better? Like any tweaks that we can make this better is that, one, we can always use different text encoders. We can use probably text encoders which are more suited to your domain. You can also try to use a bit of prompt engineering to say that, okay, we slightly change the politics to something else, which is more related to or more closer to what you want to, etc. Just change the label so that it is more related to the concept that you're trying to classify. So this is a very simple way of doing it. Like we'll see all of these things in the collab notebook in the practical session just after this. I'll just quickly go through so that you get the concept first, and then we look at the code to do this, right? So now let's move on to another model, which is called text aware representation of sentences, right? TARS for short form. So this is another a clever way of using one of our existing models or modeling setup to for zero shot classification. Sorry. So let's say this is a 2020 paper. It is pretty recent. So typically, traditionally, how a text classifier model, right, a BERT-based text classifier model works is that you have a task. Let's say I know might be too small for you, but this says that the movie was great, right? So this is a movie or a sentiment classification kind of a model. And then you have some other task and some other task, right? So for each of these tasks, we'll be actually training separate linear layers on top of it, on top of your BERT encoders, uh, because we need different set of classes. Right? That's the traditional way of text classifying. But what these guys who've come up with the paper has done is that he slightly tweaked the whole thing. And said that so you know that in BERT, right? In BERT, you can provide two different sentences as part of the single input, separated by a separator token, right? The SCP token. So what these guys have done is they have trained a model using all of these different tasks. All the tasks are trained by a same model, and how this task information and the label information is encoded into the model is by using these two separate sentences, right? So the first sentence would have something like the label and the kind of label, right? For example, if it's a sentiment classification, let's say that you say that positive and sentiment are two words that I'm giving in the first part of the sentence. In the second part of the sentence, you give the actual sentence that you need to be classifying, right? For example, if you have a sentence called "the movie was great," and we know that the label is positive, right? And we know that the task is sentiment. So how this model is going to be trained is that the first two words will be positive sentiment, and then the entire sentence. And now, after the BERT encoder or the encoder is happening, right, the CLS token is just taken up and put through a linear layer, which just classifies between true and false. So now, with a single example, you can have two statements, right? You have positive sentiment, the movie was great, and you train the model to predict that this is true. And then you have negative sentiment, the movie was great, and then you train the model to predict it is false. And similarly, for another task, probably it's a like a say, what is an abbreviation kind of a thing. So you have another task defined, and you do the same true or false kind of a methodology to train this model. So now these guys have trained this model on a wide variety of tasks, so that the model now understands the whole paradigm, right? So if it knows that, okay, if I'm given positive and sentiment, I'll be looking at a sentiment kind of a thing, and then I can probably just say true or false. So this is also a very good way of doing it. And one additional benefit about this particular method is that, in addition to being zero shot a model, this is also a few shot model. A few shot model is basically when zero shot is when you have absolutely zero training labels, right? But few shot is that you have very little, like a handful, like 10, 50, 100 or something like that, very very small data set, and you can still train a very robust model using that. right? And so this TARS model also supports the few shot mode, right? We'll see that in the practical side. So now let's move on to the next method, which is which is the one that is implemented in Hugging Face as a ready-made pipeline, and it kind of uses this kind of task, right? There is a task in NLP called natural language inference, which is a very popular task with a lot of good data sets and pre-trained models. So the task is pretty simple, right? You have a premise. Let's say that a sentence or a text, right? A senior is waiting at the window of a restaurant that serves sandwiches. So this is the premise, and then you can have multiple hypotheses. Right? That's one of the hypotheses, is that a person waits to be served food. So now what the model needs to do is you need to predict whether this hypothesis entails the premise or agrees with the premise. Does it contradict the premise, or does it have no relationship with the premise at all, right? Because if say that let's say the hypothesis is that I like ice cream, right? So it has absolutely nothing to do with what is there in the premise. So then the model has the flexibility to just say that it is a neutral one. So there are good data sets and pre-trained models which is trained to do this kind of job. Um, and f- and what we have done, or not what we have done, is what the Hugging Face guys are the forgot the name of the person, but what he has done is that just twisted this whole premise, whole task, into the way that we can use it for zero shot text classification. So here, if you see that, so the same sentence that we were trying to classify earlier, right? What are you voting? Who are you voting for in 2020? So now we make this the premise, and then we know that there are three labels: politics, economics, and public health. So we can automatically create three hypotheses saying that this is about politics, this is about economics, this is about public health. So once you have these three hypotheses, you can just run it through the NLI model, which will tell you whether it is entailment, contradiction, or neutral. Right. So now you have the entailment, contradiction, and neutral scores, or the energies that are coming out of these models. The energies is whatever is before the softmax, right? You get the raw values. So now there are two ways you can do this. One is the multi-class way. There's a multi-class way is that you have to classify it into one of these classes, right? Only one of n classes. So in that case, you just take all the energies of entailments of all the three hypotheses, apply a softmax on top of it. But if it is a multi-label, like you can have multiple labels or multiple correct answers for a particular sentence, then you apply a individual softmax for each of these three energies, and then you can have a cutoff and then say that anything which is above 0.8 or 0.7, I'm going to take it as a true label. So now this is also a very effective way, and thanks to Hugging Face transformers, it's a very easy to use, like a single line, like literally a one line code to get the predictions out of this. Um, and there are also ways of making this better, right? So we'll see that all then in the practical sessions. So now let's come to the hands-on sessions, right? I've taken a data set which is pretty recent, because I did not want this data set to be part of one of the training data which one of these big models have already seen. So just pick something which is a little more recent and very niche and like small. It is basically like a tweets regarding COVID-19, and just the sentiments according to it. Right? It is like fear, joy, anger, and sadness, right? Sad. And it's pretty balanced, as you see here. It's a pretty balanced data set. So this is the data set that I'm trying to like apply. Um, and now let's go back, go to the collab. All right. So yeah, so I'm just going to skip the first few. It's basically installations, setting up, downloading the data, importing everything that I want to, a bit of pre-processing, splitting of train data, test data, a very basic cleaning. just do a bit of label encoding. These are all standard processes that you do for any text classification. So that's why I'm just skipping over it so that I can get to the juicy parts. So this is again a few helper methods I've just defined. Right? So now, yeah. So to start off with, right, I'm just going to train a very simple linear SVC model using DFIDF and stopwords and everything, right? So it's a very simple thing to do. So you just do the training, and you get the accuracy about 66.82 and F1 of 66, right? So this is the, like, mentally this is the benchmark, right? Like using all 2000 data points that we have, we've trained a model, and that model is able to do 66% accuracies. All right. So now let's skip to the zero shot classification. So the first thing that we talked about, if you remember, was the latent embedding part of it, right? Where basically we are projecting both of our labels and text into a shared common space, embedding space, and then finding out what is the closest one. So the Hugging Face transformers have a method called pipeline, which is a very easy way to use these models. There are multiple tasks defined inside, like classification, many tasks defined. So there is one task called feature extraction. So what this will do is, it'll give you the embedding vectors from whatever model I'm specifying. And in the model, I'm just going to choose the like sentence part. Right? This is from the Hugging Face hub. You can just go there and pick any model that you want to. And in device, I'll just have a small method here so that I can run this on GPU. But then, yeah, by executing this line, the whole thing will be downloaded, and this encoder will be a callable object that I can pass my data to. So now let's look at the thing, right? So I have the sentence, who are you voting for in 2020? I also define these are the three classes that I want to classify this into, right? So now this sentence, this line of code basically converts this sentence into an embedding. So what I do is I pass the sentence into the encoder. I get an array, or actually a list inside, but I basically convert it into an array. I take a mean across the different words. So now I have a single vector, which is the mean pooled embedding vector. And this is my sentence vector. Now I do the same thing for all the labels, like all the classes inside. Same mean for all the classes inside. So now I have a list of label vectors as well. Now all that is left to do is just to import the spatial module, distance module from some SciPy, calculate the distance for each sentence vector with the label vector. So now this distance will have a list of distances. Then just get the minimum distance, the argmin, as in the index of the minimum distance, and then I get the corresponding label from it. So yeah, so then, yeah, all in 4-5 lines of code, you get that, okay, who are you voting for in 2020? It is related to politics, right? So this is like a very simple way of getting, a very naive way, in one way of getting the zero shot classification for a particular text. Right. Now that we have covered this, let's move on to a slightly more sophisticated way of doing it, which is the TARS model. The TARS model is actually implemented in Flare NLP. They also have a pre-trained model available, which is easy to use. Right. Again, so all you need to do is, of course, install Flare NLP, and then from Flare.models, you import the TARS classifier. And then also import the sentence, because like Flare NLP has a way of a standard way of input taking in inputs, and which is through the sentence class. So now you can just use this line to kind of load the pre-trained task model for English. Right? So once you execute this line, everything is going to be downloaded, and the model is initialized. So now there are two modes of operation for tasks. One is multi-class and the other is multi-label. So in the multi-class, You say that, okay, I have a sentence. I give the sentence text, right, as an argument to the sentence class, because that's how Flare NLP works. Then you have the classes. These are the different classes that I'm interested in. Then I do a task.predict zero shot and give the sentence. What are the different classes? And just an argument saying multi-label is false or true. So once this is done, how Flare NLP does is it calculates or it finds out the label, it stores it inside the sentence object itself. So after you execute this, if you print out the sentence, you can see that this is who are you voting for, and the label is politics. It is related to politics. So it's been able to do that in very, very simple way. Sorry. So now let's move on to the multi-label way of things, right? So multi-label is when you have more than one right answer or what we want to. So I've just kept the same. The only thing I've done is I've added one more label. So now this sentence can be both about politics and elections, right? So now if you do the same syntax, but just that multi-label equal to true, you can see that the sentence is having a high confidence for politics as well as elections. So this is how easy it is to use the task model as well. Um, right. So after this, right, examples, we also look at the effectiveness, and like we run this on the test data to find out how well these are doing. So we'll look at that at that point. So now look at the third one that we have, right, which is the Hugging Face task, right? Like I said, there is a pipeline. There are multiple tasks, right? One of the tasks is zero shot classification. So it's you just need to have a pipeline. Tell that I want to do zero shot classification. Choose a particular model from the hub, and then just execute. Right now, like the encoder object that we had earlier, this classifier does the exact same thing. So now, if you have a sequence, like say this is my sentence, right, and these are the candidate labels. All I need to do is I have the classifier. That's a callable object. Then I'm just going to pass my sequence and my candidate labels. It gives me back the answers saying that politics, the score is 0.97. The others are very small. So that's it. Literally a single line of code. And similarly for multi-label, you just need to multi-class. But yeah, you just need to say that it is multi-class equal to true so that it becomes, so then for politics and elections, you can see it is the scores are high. Right, so that's as simple as that. So yeah, this I'll just skip. This is basically I'm just evaluating it on one of the training sample examples, but it's pretty much the same as we just saw. So let me just skip and then say that. Okay, then I've also done the evaluation using the test set. Right, I've not used any training or anything like that. Just evaluated on the test set. The code is pretty much the same, just adapted for the entire thing, right? Just run a loop over it and then scoring it. So, and then just calculating everything. So then, yeah, so for the latent embedding, we can see that I have a test accuracy of about 49% and an F1 score of 47, right? Which is not great, but considering that we've not used anything is good, right? So yeah, we have a accuracy of score like this. And similarly, I've also done the same thing for the task model. For the task model, just as one small thing I probably want to add here is that the default, the predict zero shot method that we saw earlier, right? Sometimes that does not give any predictions, right? And that's one of the issues which is there in TARS. I think something's there is an issue in the backend. Whenever it is a negative energy, it kind of ignores the whole thing. So basically, the thing is, when the model is absolutely not sure that any of these things are there, it gives you a zero or empty list. But just that we did not want that here. So then I just made a small change in the way that we are calling it. I'll probably just explain it as well. So the first one is same. I just load the model, and I also create a dictionary of sort. It is basically a a Flare NLP kind of a Flare NLP object, which holds all the labels, right? What is the labels and all that. Then I get this task and I just like add and switch to new task, and I gave the task name as zero shot and the label dictionary and everything, right? So now I've indicated to the task model that I'm going to do zero shot learning or zero shot classification. Uh, then I just basically create a list of all sentences. Then I use the predict method for tasks instead of the predict zero shot. And then here I have the ability to give, say, label threshold equal to 0. So that this forces the model to give some prediction, even if it is not confident of anything, right? It will give some prediction. So just did that small tweak. And I think the issue is already resolved in the master branch or something like that. But yeah, so now I've just ran this on the entire training data and evaluated it. So now you can see that it is 45%. It's actually worse than the latent, like latent embedding approach, which is not very good, right? All right, let's move on to the next one, which is the Hugging Face one. Similar, no fancy code, just a loop over everything. I'm scoring all the predictions, and here I'm looking at the accuracy, and then I'm getting pretty good, right? It's 52.9. Keeping in mind that my best performance using 2000 labels is 66%. So without any label, I'm getting 52, which is pretty decent if you ask me. But yeah, so we're not done here, because like we told earlier, right, there are many things that you can do to start making these models slightly better, right? So one is prompt engineering. So by default, the NLI, or the zero shot classification, the task, what it uses is that the default prompt inside when you're creating the hypothesis is that this example is the label, right? So now you can always try and change that prompt. So we know that this, we're talking about emotions, so we can always say that, okay, the emotion is label, right? So it's also very easy to just change it, right? It's just give it like this: the hypothesis template, the emotion is parenthesis. So I've basically done that, these kind of experiments for a few. I'm just scrolling to the summaries page, but done it for a few prompts. Where's this? Oops, sorry. Yeah, so I did it for a few things, which is the emotion is, or the emotion in the text is, or the person is feeling. Like basically these prompts, the only limit is your creativity and how you can kind of ask the right questions. So here you can see that, okay, all the prompts that I've used are not doing well at all. Like it's not even close to the best one that we're having. Uh, but then, yeah, there are other ways of looking at this. So till now we were using a model with the Facebook MNLI model, right? But now we can always try and change the backbone that we're using. And typically it pays to use a particular backbone which is trained on a data which is as close to your data as possible, right? So for example, in this situation, the data that I'm trying to predict on is tweet data, right? Data that people have written. So a very close alternative would be like the large MNLI model, which is run on or trained on Yahoo Answers, which is, again, if you are old enough, you remember that Yahoo Answers are similar to Quora. You have in the like early sometime before. So they are also basically kind of people have written those text, right? So that text has a chance of being more closer to the kind of distribution of text that we have in our test or our training data, our test data, right? So then we just choose one of these models which is trained on Yahoo Answers. The rest of the code is the same, right? Then let me also just skip to the summary. Yes. So I just ran all these different prompts that we had using the new domain adapted model. And here you can see that the domain adapted model is actually performing quite well. And even the different prompts, right? So that the prompts which were not working at all earlier now started working. So you can see that the emotion in the text is now doing pretty well, right? It's pretty close to the default model. So it is basically like a combination of multiple things that will start working for you in many case. So it's really about really depending upon your creativity and your um, willingness to explore different things. So now let's look at the summary of all the things that we just ran, right? Um, like the baseline supervised is 66, that is the top there, and then you can see that the default Hugging Face NLI and the domain adapted one are pretty close, right? Let me just go back here. Okay, let me give it a minute. All right, so here you can see that it is pretty close, and like 52, one of it is having a higher accuracy and the other is having a higher F1 score. So both of them are pretty good models. So now that we've seen that this is all that we can do, right, in the zero shot way, which is pretty awesome. If you ask me, right, you have very good accuracies, very close to good accuracies without having any label. But it's also important for us to understand the limitations of these approaches, right? And there are a lot of limitations, especially from the practical point of view. Um, for example, the first one is just named it common sense, because zero shot classification only works when your labels are also common sense entities, right? So in our case, right, you have anger, sadness, joy, and all that. Those are all very common sense classifications. Right? It's language based. But let's say that you're working in a company and you have a very unique way of categorizing things, and then you want to do it that way. Then odds are that this is not going to work that well, right? And another major problem, which is around evaluation, uh, which is because zero shot by definition is without any labels, right? But then without any label, how do you evaluate models? Like in our case, we just use the labels uh, because there were labels. We were just not using it by choice, right? But in a real application, you will not have any labels to check this model if it is doing well or not. So then doing model selection, doing hyperparameter tuning, anything in a quantitative manner becomes impossible to do. So that's another drawback. Then you also have that it is highly dependent on the language that you use. Like we've seen in the examples, right? The prompts that we use or the kind of model that we use actually makes a lot of difference. And this, coupled with the lack of ability to evaluate a model, makes it a little bit difficult to put together a trusting system which does it, etc. Right? Um, Most of these issues may go away in the future, as this is still a very nascent stage. But yeah, and the last point is that, like, at the end of the day, if you have to evaluate, you have to do some labeling, right? But if you're anyways doing labeling, why not just do a bit more labeling, right? If you're planning to do 50, why not just do 100? It'll take hardly half an hour more to actually do that labeling. So then, isn't it a better way to just go for a few shot way of doing it, right? So the ideal way would be a combination of all of these. Like basically, start with zero shot and then slowly move towards a few shot. But few shot is a very good way of doing it, and which is my next topic, right? Few shot classification. Let me go back to yes. So now let's say I'm following up with the same logic, same example, but instead of taking zero training sample, I'm just taking 50, 52 to be exact, from the training data that I have, right? And then I just trained same code. I just trained the same model with just these 50 items, right? So now I have a model which gives me, this is my linear SVC model, 46% and 45%. Now this is actually worse than the zero shot model. So if you're wondering, if you only have 50 or close to 50 labels, don't even try doing normal text-based classification. It's always better to just use the common sense which is there in our large pre-trained models, right? But anyways, moving on. So one of the ways that you can use these 50 labels is the standard way of fine-tuning BERT, right? BERT or any other large model that you want to. So fine-tuning BERT is something that everybody is, like, you can find a lot of resources everywhere, right? So I'm just going to skip how I'm doing it. But basically it's very simple. You train, right? So once you train the model and you predict on the thing, right? So the accuracy that I'm getting is again 45%, which is pretty much the same as our default model and worse than our zero shot model, right? So now let's say that, okay, earlier I told you that TAS has a few shot mode as well, right? So now this is a bit more involved, but let me just take you through. So how a flare dataset or flare model is you can train is that first you need to have a flare data point dataset, which takes in a list of sentences which we used earlier, and for each sentence you can add a label, right? I'm saying that this is my label, and I also name the label as this is an emotion label, right? So this whole line, I'm just creating a flare data point set, which is looping over my training data or the 52 lines that I have. Then similarly, I create a test one. Then I basically make a corpus, which is basically I just put the training and testing together. Then I also make a label dictionary, which is basically like it's like a boilerplate code, right? You don't need to do anything. You just need to write this line. It will create a dictionary internally, which is being used inside. And then we import a model trainer. Then now we start as usual. We load the task model, the pre-trained model. And now this is where the magic happens, right? You add and switch to new task, and I name a new task, right? This emotion is a task which I am defining now, right? And then I say that this is the label dictionary which is associated with this task, and this is the label type, which is basically the same name that I've given here when I'm adding the label. So now task model knows that, okay, I am going to switch to a new task and I am going to see some data for training this. Now I create a trainer by passing the model and the corpus, then do dot train. A few parameters like learning rate, epochs, etc. So once this is trained, the model will be saved in this path that I've given, right? So let me skip. So now the model training is done. Now I'm just going to load the model where I've saved. Again, after loading, I'm going to switch to the task that I have trained it for, right? I need this emotion train thing. Then I'm just going to predict on all the data that I have. So now when I am evaluating it, we can see that, okay, by using this 50 data points, we've got a good enough accuracy, right? We have 54% accuracy and 52% as a F1 score, which is slightly more than the zero shot way of doing it. Oops. Yeah, I think I'm frozen out. But anyways, I hope you guys can still hear me. Yeah, so what happens here is that this model is actually doing much better than, or slightly better than, the zero shot model that we had, right? And give me a second. Right. So if you look at it from the other way, right, you have the baseline supervised model, which is 66.8, which is my our top line. You have the two best models from the zero shot paradigm, which is 52.9, 52. And then by using of 50 label data, we have 54, right? So when you're faced with such low data situations, right, one of the things that I probably suggest to do would be to start off the whole process by using a like a zero shot model, right? By having that model, and then you have a prediction on all of these things, right? Then you can, using the confidence and everything, you can kind of do somewhat of an active learning approach and find out a few labels where few data points where the labeling makes a lot of sense. So you start labeling them, switch to a few shot paradigm, repeat the process, find out points or data points which are best to be labeled again, and then you keep iterating until you have a model which is doing um, as well as you should hope, right? So that's with that, I think we're coming to the end, or we have come to the end of the session today, and the hope is it's still in time, right? All right. So yeah. So if we have any questions or anything like that, right, we can take that right now.
Yeah. Thanks a lot, Manu, for
Yes.
that extensive presentation. Um, actually,
Yeah.
I was getting a few questions here and there, but then you kept on answering them one by one in your
Okay.
presentation, which is an interesting thing. Um, I think there are a few questions. Supreet, you want to pick them?
Sure. I think I can see one from Bella where she's asking if an existing model can an existing model used for zero shot be fine tuned? And I
Hmm.
yeah. And
Right.
if yes, what's the way to go about it?
Right, right. So that is the last thing that we just talked about, like
Yeah.
the few shot classification, right? That's basically fine tuning the zero shot model to a new task. So you have a very small data set. You kind of saying that okay, this is a new task. You kind of learn something specific regarding this particular task. So that is as close to fine tuning as you can get from the zero shot world. I
Okay.
hope that answered
And
your question.
yeah, yeah. And also, just wanted to know, like, since you mentioned that it barely takes around at times 30-40 minutes only to have a few set of, label data, then why does somebody even start off with zero shot learning? Why even have it in place?
So one thing that I can think about is that, so suppose there is instead of a standard, say like a standard text classification scenario, right? You have the labels which are very constant, like you always need to do these three, four, five things.
Mm.
But in a hypothetical situation where that itself is slightly changing, right? You have slightly different things to be classified depending on the situation, then probably a zero shot model can be an thing. But then again, let's not fool anyone, because a supervised model is going to be better than zero shot or few shot any day. So if you have the time and money
Yes, yeah.
for annotating, by all means annotate and then do it. But if you don't have the luxury, then you need to kind of make use of the data, best use of the data that we have.
Mm-hmm. Okay. And
I have
uh,
a question. Sorry, Mudit, go ahead.
no, no, no. Please go ahead, Supreet. Yeah.
Okay. Okay. So I have a question on, the, I wouldn't call it the right quantity, but do you consider this being a very data intensive load, the entire process, or do you think if a company is kind of dealing with problem or a situation where they don't have enough data to train their models, do you think will these algorithms still work?
Yes, provided that the context is related to common sense, right? Like it's
Hmm.
general language related concepts.
Hmm.
So how we can think about is that, so when you're training a model, you're giving a few data to that model, right?
Correct.
So in a standard paradigm, that data or information present in that data is the only thing that the model is capable of learning, right? The best case scenario.
Yeah.
But that's where these kind of foundational models or these pre-trained models that we are having comes into a good kind of perspective, because it has more knowledge than the data set
Yeah.
that you are trying to train with. So you're bringing something from outside. So
Correct.
kind of like cheating, but that's how uh, things are.
Yeah.
I mean, that's how you and me work as well, right? You don't, yeah.
I agree. Okay. So there's one question that I would like to take from audience, Madhut, and then probably you can ask the next question. So the question is, does any of these models deal with sarcasm while predicting emotion?
Yes, no, sarcasm. I mean, it potentially can, but sarcasm is a very difficult thing
Correct.
to detect. Like especially in text, right? You can say a word in the right tonality, it becomes sarcastic, and if it is not, if it is, it's a very decent sentence. So it depends a lot on the context, and like if it is a multimodal kind of a thing, right? If you have voice as well associated with it, then yes, it's slightly easier to find out. But even then, like humans also struggle in finding out sarcasm if it is veiled correctly.
Yeah. Okay. Hmm. Got it. Yeah. Uh, Thanks for asking that, Tamana. I think that's a great question. Um, by the way, Lereko says hi. There are many community members who have come forward and said hi. So yeah. Um, this one question that I had. So, is there a particular use case where? So, you mentioned a
Yeah.
few limitations of, a zero shot TC, but is there a? And then you went ahead to, you mentioned talked about three models around zero shot TC, right? So, let's say, is there a particular use case where one of them works better? Let's say TARS is working better in these specific set of cases, or so on and so forth.
it's it's going to be difficult to say, because as everything in machine learning, right, you don't have a solid answer. Like you can't say that XGBoost, I mean, XGBoost is an exception, but you can't say that this particular model works well in any place. Like
Mm.
there is that no free lunch theorem. But yeah, I think TARS is something that I don't know. I am a little bit biased towards because of the few shot capability,
Mm.
because the fact that you can enhance the model by a little bit of data. The other models are do not have that. Like it is static, right? You don't have a way to kind of tweak, or a lot of ways to tweak that model.
Mm. Okay.
Awesome.
There are a set of questions that, yeah, Supreet has picked them. So, yeah,
Yeah.
Supreet.
So
Right.
Hmm.
I think if you can see from the screen,
Yeah, I can
yeah,
see it
Manoj,
on
you
the
can
screen.
answer that. Yeah.
Yes. So yeah, I mentioned Wikipedia as like a stand-in of things, but most of these data, most of these models, right? It is being trained on, um, let's say, all of. I'm not exaggerating when I'm saying all of internet. So it has seen a lot of data. It has a lot of knowledge within, right? It has memorized or understood or some ways a lot of these things. So Wikipedia is obviously inside the corpus that these large models train on, and more, right? So yes, all of these information, anything which is in the textual format, is kind of getting encoded into these large models, which is what we're using as the backbone of all of these zero shot, few shot, everything that we're using. The backbone is actually these large language models.
Yeah. Also, have a quick question here. So, I think that, I think I'll probably pick this one because there are two questions. Okay. First off, would you share the link for the collab? I think a lot of people had asked
Yes.
for it. Yeah.
Yes.
So we'll put that in the comment section towards the end. Probably you could share it across via chat section, and I'll
Yeah.
put it across. Okay. And for those who are watching it later, I think we'll add it in the content section. Supreet has picked a question. So yeah, a fairly long one.
How can we
Yeah.
fine
So
tune from there? I think the first one, I think we've answered, right, the few shot models. So not everything can be fine tuned. The task model does have that facility. If I have an imbalance, not able to extract. Okay, so when you're saying label sample ranging 10 to 500, it means that you have 10 samples or 500 samples, or like approximately 500 samples of data. If
Abhinav, if
that
you
is
can
the case,
clarify, then yeah, but sure, go on.
yeah, no, if that is the case, then if you have 500, I think you can start doing normal fine tuning also and see if it works, right? 500 is pretty decent.
Hmm.
Yeah,
Yeah, in
Um,
few shot, we're talking about tens, 50s, and hundreds, of that sort of data.
wow.
okay. There's a quick question from Lerico, which says, "Can I use zero shot TC to predict the stress?"
Stress in human life.
Uh,
Put it across, I thought you maybe you. I was hoping you wouldn't ask that, and you'll get it. Okay, but yeah, maybe Lerico, you could clarify your
yeah.
question further by what you imply through stress.
And I
Uh,
think Arvind has also commented that some labels have 10, others have 50, others labels have 500. Sorry.
okay, this is slightly tricky because the first question was by Abhinav, and this is put across by
This is by
Arvind.
Arvind. Okay, I think it's like I'm assuming that it's kind of a part of that
Hmm.
question. So, yeah.
Yeah,
Right. Some labels have 10 and other labels have 500.
this was the original question, by the way, fairly.
Yeah.
Yeah, no, I'm further confused, I think.
Um, Arvind, if you could
Sorry,
make it
Arvind. Yeah. If you can
simplify it.
make an attempt to make that clear, right? Because labels um are okay. So
Oh,
you're saying that some labels have only 10 data, 10 points, and some of them have
Some,
500 points.
hmm.
Okay. Hmm. Class imbalance is right. So class imbalance is difficult to, and it's not. So class imbalance is not something that is handled by few shot by ISO because it's there are other ways of handling these things, right? Data augmentation, although there is, right, I'm not a big fan of it, but there are there's also you can kind of, if you're training a neural network or even the standard ML methods, right, you can have this class weights, which you can use to kind of encourage the model to learn your low, like 10 samples, 10
yeah.
label samples, right, better. I'm kind of more biased towards that kind of a method because that's more closer to the test scenario that you are actually having. The other ways it might not work a lot more. But then, yeah, you can always, this is all about experimentation, right? So you can always try if this 10 or 20 or the very low labels, sample labels
Mm,
can be worked with a few shot, and then probably the rest of it can be handled by another one. But you can probably try that approach.
Hmm. There's a question that I was, which is an interesting one. I think yeah, it's around zero shot learning as a whole, but can we use it in computer vision as well? Are there any other domains where zero shot learning is used?
Yes. So actually, the techniques are different, but computer vision also has a good collection of techniques which does zero shot learning.
Hmm.
I'm not an expert in that, but I know that there are a lot of methods there.
Okay. So yeah, I think we are towards the end of the
we
question.
are good
I have a quick
to-
question. So generally, these zero shot TC models, they are inherently interpretable, or something like Shapely has to be on top of it. I mean, how does it work?
No, interpretability is going to be a problem. It's a challenge because uh, at the end of the day, we are basically using one of these large language models, and a lot is dependent on what that model has learned, right? I'm not saying it is impossible to get it. Like you can get probably the attention weights, or you can probably even use Lime or something like that to simulate what's happening. But not as interpretable as, like, interpretability is very subjective matter, right? If you ask me, a decision tree which is say 5 levels deep is also not interpretable. So it's a very subjective concept, but in one way, you can understand what the model is doing in one way, kind of looking at the attention weights and probably lime or gradient based, saliency based methods, etc.
Okay. By the way, Abhinav says thanks to Arvind for clarifying, and thanks to you also. What you answered serves as a good starting point. So
Okay,
yeah.
yeah, glad to be of help.
And now
Mhm.
Arvind has asked the last question. For inference, is GPU a must, or can it be done on a CPU? Okay.
Can be done on the CPU as well. I
Okay.
mean, not using huge GPT-3 models, right? BERT and all is normal models now.
Yeah. Okay. And what for GPT-3? I mean, for that one needs a GPU, I guess.
Yes. Yeah,
Okay. Yeah.
GPT-3 is not even. I mean, you can't even if you have a GPU, you can't be running it. You need to have
Right.
multiple GPUs and yeah.
Okay. Yeah. Right. Okay. Fair enough. So I think yeah, we are done with the questions. It was yeah. You have also shared the link for the data set. I think yeah. I'll put it across. Okay, this is the link for the database community. Okay, I'll put it across in the on LinkedIn as well because by default it doesn't get posted there. Manu, could you share the link for the collab as well?
Yeah.
Oops,
Just share it in the
Okay.
private.
Private chat.
perfect.
Okay.
Yes. Okay, we have posted in the comment section for uh, YouTube. I'm posting it in the on LinkedIn as well. So yeah, great. It was perfect talking to the community today. Thank you so much for being here, and thanks a ton, Manu, for this very elaborate and kind. I would say, yeah, you took your time out on a weekend evening. So thanks a lot for that. And there are people. I think Supreet is one of those who join us every weekend morning, which is probably the most difficult thing on planet Earth. So thanks a lot to those who are joining like that. So thank you so much. Uh, we'll see you soon. There's another live session coming up. So we generally do this on Saturdays, but there is an exception. There's a session coming up on Wednesday on Tesla Autopilot ML platform. So if you want to check that out, go to the event section of our LinkedIn. You'll find it, or even DPhi's website will give you a link for it. And yeah, do follow Manu Joseph on LinkedIn. He's there. You can also follow him on other platforms, I believe. Are you on Twitter, Manu? I guess.
Yes, yes.
Okay,
Manu
great.
Joseph B. I think same.
Okay, awesome. Great then. Also, Taman, I think he happens to be a part of Thousand Tech itself, but yeah, he says thanks a lot for the session. So, thank you. We'll see you all soon. Bye.
Thank
Thanks. Bye
you.
bye.